Farmers have been growing crops for thousands of years. Over time, they have developed different types of crops. Two important types are traditional crops and hybrid crops. Traditional crops are varieties developed over generations through natural selection by farmers. These crops are well suited to local environments and farming practices. Hybrid crops, on the other hand, are developed by scientists. They are created by cross-pollinating two different parent varieties with desirable traits. This process results in offspring, called hybrids, that often display improved characteristics, such as higher yield or better disease resistance. An example of a traditional crop is the heirloom tomato. These tomatoes have been passed down through generations of farmers. They are known for their unique flavors and adaptability to specific regions. An example of a hybrid crop is maize. Hybrid maize varieties are widely grown throughout the world for their high yield potential and resistance to common maize diseases. Traditional crops often possess some degree of resistance to local pests and diseases. This resistance is a result of natural selection over time. Farmers would save seeds from the healthiest plants, which were often the ones most resistant to pests and diseases. These seeds were then planted the following year, gradually increasing the resistance of the crop over generations. Hybrid crops, on the other hand, are bred for specific resistance traits. Scientists can screen different parent varieties for their resistance to specific pests and diseases. By crossing two resistant parents, they can create hybrid offspring with even greater resistance. This targeted approach allows for the development of crops that are highly resistant to prevalent pests and diseases in a particular region. However, it's important to note that not all hybrid crops are inherently more resistant than traditional varieties. The level of resistance depends on the specific parent varieties used and the breeding process. Integrated Pest Management, or IPM, is a holistic approach to managing pests in agriculture. It involves using a combination of methods to keep pest populations below levels that cause economic damage. IPM strategies aim to minimize the use of chemical pesticides, which can have negative impacts on human health and the environment. One key principle of IPM is understanding the life cycle and behavior of pests. By knowing when pests are most vulnerable, farmers can target their control methods more effectively. Another important aspect is monitoring pest populations. Regular scouting allows farmers to identify pest problems early on when they are easier to manage. IPM also emphasizes the use of preventative measures. This includes practices such as crop rotation, which disrupts pest life cycles, and planting resistant varieties, which reduces the need for pesticides. Biological control, which involves introducing natural enemies of pests, is another important tool in the IPM toolbox. Section 4. Hybrids, Traditionals and IPM, a winning combination. Both hybrid and traditional crops have a role to play in integrated pest management. Traditional varieties, with their inherent adaptability and often unique resistance traits, can contribute to the diversity of an IPM system. This diversity makes it more difficult for pests to adapt and overcome the resistance of a single crop variety. Hybrid crops, with their potential for high yield and targeted disease resistance, can also be valuable components of IPM. By reducing the incidence of pests and diseases, these crops can minimize the need for chemical interventions. However, it's crucial to avoid relying solely on a single hybrid variety, as this can lead to the development of pest resistance. The key to successful IPM lies in integrating different approaches and utilizing the strengths of both hybrid and traditional crops. By combining resistant varieties with cultural practices, biological control, and judicious use of pesticides, farmers can effectively manage pests while minimizing the negative impacts on the environment and human health. Section 5. The future of farming, a balanced approach. As we look to the future of farming, it's clear that a balanced approach is needed. Hybrid crops will continue to play a vital role in increasing food production and addressing the challenges of a changing climate. However, we must not overlook the importance of traditional crops, and their contribution to biodiversity, resilience, and cultural heritage. By embracing both hybrid and traditional crops within an integrated pest management framework, we can create more sustainable and resilient agricultural systems. These systems will be better equipped to deal with the evolving challenges of pests, diseases, and climate change, ensuring food security for generations to come.